In this video, we're going to look at how to find the magnitude of a given vector. So let's say the vector I'm dealing with is the vector A, and it's equal to 4i plus 2j. So that vector is going to look something like this. It's going to be angled upward and to the right because it's made up of 4 unit vectors to the right in the positive x direction and 2 unit vectors going upward in the positive y direction. Now, to figure out the magnitude of this vector is actually based very closely on that information that makes the vector itself. Again, the key thing here is that this vector is made up of 4 of the unit vector going to the right and 2 of the unit vectors going up. And once I've drawn that actually into the diagram, you can see that between the vector itself, A, and the unit vectors or the basis vectors that went together to make that vector originally, I have a right-angled triangle. And so it stands to reason then that I can use Pythagorean theorem to figure out the length of vector A. See, remember, vectors I and vectors j are unit vectors. That means that they're all of length 1. And so that means if I was just to consider this for a moment as a triangle and not worry about the vectors, the bottom side of that triangle is of length 4, and then the right side there is of length 2, and so using Pythagorean theorem, I can solve for this side, which represents the length of vector A. So I know that that length squared is equal to 4 squared plus 2 squared, and so what I end up with is that the length of that vector is root 20. So in general, that strategy is always going to be able to work to help me find the magnitude of a vector. Doesn't matter how the vector is written. If I have a general vector u, it'll be written with basis vectors like this, or it could be written in column vector form like this. But based on the strategy we just used, we know that ultimately to find the magnitude of that vector, I'm going to take the x component and square it, add the y component squared, and square root the result. So that formula is based off of Pythagorean theorem, but because all of our vectors are made up of horizontal and vertical components, we can apply it in this situation too to find the magnitude of any vector we're given. Knowing how to find the magnitude of a vector can be really useful because it helps us check if a vector is a unit vector. Let's say I have the vector j, and I know it has components 3 over root 10 and negative 1 over root 10. And I want to know if that's going to be a unit vector. Well, the easiest way to verify this is to just find the magnitude of that vector. So I'm going to take 3 over root 10, that's the x component, square it, and then take the y component, which is negative 1 over root 10, and I'm going to square that and square root the result. And so when I do that, here I get 9 over 10 plus 1 over 10. So it's the square root of 10 over 10. That's the square root of 1, which is just 1. So by quickly checking the magnitude here, I have verified that this is, in fact, a unit vector. If I got a different result, if I got that it wasn't equal to 1, then I would know that this vector was not a unit vector. This can also be helpful if I'm missing one of the components of a vector. So if I didn't know the x component or the y component, but I knew a vector was a unit vector, I could use the same sort of logic, but I'd have an unknown value in the place of one of those components that I would be solving for. And so being able to find the magnitude of a vector then helps us in a lot of ways. It's actually going to become even more useful as we learn more skills about vectors going forward.